Hello. Today, we are going to review an article on HCI. Well, it will actually be on BCI, or brain-computer interfaces. The article in review is a snapshot of the current state of research and development of BCI as of 2021. The article covers how BCI works, the methods used to gather the data, signal acquisition, filter the data, signal processing, understand what the data is, feature extraction, apply the data to the mental task the user is performing, classifiers, and finally use the results to control a device. The article covers each of these in detail, going over what was being used by researchers and how effective the methods used are. I will very briefly go over each step in the BCI system mentioned in the paper. Let's dive into the meat of the article. First, the article gives you a great visual to understand the flow of BCI. Keep this in mind as we go over the different steps in creating a usable BCI system. The process of capturing data from the brain starts us off. Several methods are used. The researchers broke this down by how invasive the sensors are, from full brain surgery to an electrode on the scalp. At the time of writing, the electroencephalography, or EEG, is the most predominantly used method for collection. Why? It is cheap and the least invasive. While this method is the most widely used, it is not the most effective. When trying to collect data from anything, the closer to the source you get, the better the data. The same is true here. If you want clean data from the brain, you need to have your sensors in the brain. These methods are not discussed at any length due to the rarity of this method being used. I am sure you can imagine why. Now we have some data from the EEG. We need to clean that data up. Every movement, sound, and stray thought will impact the readings. So first, the research environment is very controlled. But this in itself is an issue. If you are going to build in BCI, it will have to be used in any environment that a computer is used now. Noise, lights, and other distractions included. The paper makes mention of this, but as an overview or state of BCI doesn't include solutions. Signal processing is done on our collected data. Noise has to be removed to help identify clean features. Signals are classified into three groups: evoked signals, spontaneous signals, and hybrid signals. The signal data collected is often gathered into a dataset. A dataset is the signal data gathered during a predetermined set of exercises for the user. There is a collection of dataset types available to researchers to use, or, of course, create their own. The hardest part of generating a dataset is the collection of signals through a controlled means. Each session will have different signals collected while completing the same exercises with the same subject. These data collection sessions are taxing for the person, requiring long intervals of focus and concentration, which of course means several sessions. Once this dataset is collected, it can be processed by several methods. Usually a combination of methods is used to achieve the best results. Now, with clean data, we can begin to look for features in the data. Once again, there are several methods employed, and usually more than one is used on the dataset to find features. BCI classifiers are recognized features that can be used by the system to control a device. Once again, many of the methods presented are used to find a usable result. Neural networks are some of the more complex methods used to help classify features. This section covers some of what seem to me the most complex parts of creating a usable BCI system. Once all the classifiers are created and tested, the researchers need some way to validate the effectiveness of their chosen methods. The article covers several and comes to the conclusion that the BCI community needs to build and adopt a framework to measure the effectiveness, thus allowing an easy way to identify methods that are effective across the community of researchers. Finally, the article covers the limitations and challenges for the new methods used by the research papers used for the article. The three categories used in the article are usability, technical, and ethical challenges. With BCI 3 years later still in its infancy, the challenge of building a solution that is usable, ethical, and technically affordable is still far away. I have covered emotive, a BCI solution, in another video, and I wrote a brief article on the ultimate HCI where I talked about BCI and some of the moral and ethical issues. I still believe the ethical challenge to be the hardest to overcome. If we just looked at it from a physical perspective, if you want clean signals, you need to get close to the source, and that means getting into the brain. A recently, 2023, Neuralink blog has asked for volunteers. While questionable, the step must be taken to further any development of a quality BCI. The stated intent of the article was to introduce lay people to the state of BCI and the technology and methods available to researchers. It does achieve this. There are sections that are very technical, but still have a good summary to help you understand what is being accomplished. I am sure it is dated, being published in 2021, and could use an update, considering the advancements in machine learning and AI in the last 3 years. Overall, I believe it to be a great article for people to get a handle on BCI. Once again, thank you for watching.